this chapter, we will be looking at topics related to measurement. In this lesson, we will be looking at the surface area of pyramids and spheres. We will begin by looking at pyramids, specifically square pyramids.
So to begin in this lesson, let's start with what the definition of a pyramid is. So it's a three-dimensional object with a base, and when we're talking about a base here, so it's going to be some sort of a shape. Okay, now for our purposes in this course, it's going to be some sort of nice regular shape here, but it's going to be just your standard shape. So it could be like a square, a triangle, a rectangle, hexagon, whatever, it doesn't matter, but it's going to be some sort of regular shape here with the same number of triangular faces as there are sides. So you've got your base down here, some sort of a shape, whatever it is, and then there's a point up top here, and then we're going to drop these rectangular faces where the base of each rectangle is going to correspond to a side of the shape below. Now we're going to start with a square pyramid. And one of the things you got to be aware of here is that in the vocabulary, sometimes you're going to see these referred to as right pyramids. And what we mean by that is that the apex of the pyramid is going to be directly above the center of that shape, okay, at a right angle. It's not going to be skewed off to any side here. Okay, it's going to be right dead center. So, and then you're going to get these, in the case of a square pyramid, you're going to get these four sides here. And these four triangular sides are all going to have the exact same area, if it's a square pyramid. Now, when we're coming up with the surface area, then what's interesting to us, or what's important to us, is the slant height. Because in order to get the surface area of a pyramid, what we need here is we need to know the area of that triangle. Now, granted, there's going to be the height to the pyramid, but that's not the height of the triangle. I mean, if you were to rotate that triangle up along the base here, you'd find that that triangle is actually higher than the pyramid itself. And we need this length right here to figure out the area. Now, that is typically going to require the use of the Pythagorean theorem, because we'll have a right angle triangle formed by the height of the pyramid plus the distance from the edge here to the center. And then you've got the hypotenuse, which will be the slant height. Another way you're going to see that written here is you'll have L for the length of the sides here, H for the height of the pyramid, and then we'll use S to represent what we call the slant height of the side of the pyramid, the triangle. And that gets us this equation right here for the surface area of a square pyramid. You're going to get the lateral area, the sides, remember there are four triangles, then we're going to add the area of the base. Now in this case it's going to be a square, but it doesn't have to be. And this typically works for this idea of lateral area plus area of the base, works for any pyramid. But in this case here, what we've got here is, because it's a square pyramid, it would be 4 times the area of the triangles. Now remember, you're always dividing by 2 with an area of a triangle. So 4 divided by 2 is going to get you 2. And then we're going to have the length of each side along the base of the square pyramid, and then the slant height, plus the area of the base, which would be L squared. Okay, so now you got a sense of what we're doing here. We're really just taking the pieces bit by bit, putting them all together. Let's take a look at some examples. Okay, so let's find the surface area of the following shapes here. So again, we've got a square pyramid, 6 by 6. And then we're told that the slant height here, it's not coming in very clear, but it's supposed to be 12. Now, in this particular case, this is meant to just be kind of an easy first step into this. So our surface area is going to be 2 times the length of the base times the slant height plus the length of the base squared. So that's going to be 2 times 6 times 12 plus 6 squared. Okay, well 2 times 6 times 12 will be 144 plus 36. And so we're going to get 180 centimeters squared when all is said and done as the surface area for that square pyramid. Okay. Now let's take a look at another one that's probably a little bit more like what you would expect on an exam here. So the length of each side here is 10, and we know that the height is 12. Okay, so we don't know the slant height, but I do know that length right there has got to be half of the side length. Okay, because there's another part that's missing, and they're symmetric. So if that's 10, this has got to be 5. And so now the Pythagorean theorem, here's S. So I know that S squared will equal 5 squared plus 12 squared. So 25 plus 144. Okay, that's going to be 169. And I know that the square root of 169 is going to be plus or minus 13, but in this case only positive 13 really makes any sense here. So that's my slant height. So there was the first thing I needed to do here. Okay, so now my surface area is going to be 2 length times the slant height plus the length squared. So 2 times 10 times 13 plus, oops, sorry, not 13 squared, it's 10 squared. Okay. Well, 2 times 10 times 13 is going to be 260, and then 10 squared is going to be 100. So this is going to, oops, sorry, you couldn't see that. So this is going to end up being 360 units, whatever the units are, squared. Okay, because we're looking for area. So in this question, we read that the model of the Great Pyramid of Giza is constructed for a museum display. The surface area of the triangular faces, okay, now that's plural, is 3,000 inches squared. That means all of them together, 3,000 inches squared. The side length of the square base is 50 inches. Determine the height of the model to the nearest tenth of an inch. Okay. Okay, well what we need here is we need to figure out something about the slant height there. Because what we've got here is, here's our pyramid here. We know that this is going to be 50 inches, 50 inches. We have enough information to figure out what that is. What we're interested in is what the height is. Okay? Now, 50 times 50 is going to be 2,500. Okay? Oh, sorry, I don't even know why I did that. There's no reason for that. I know that the surface area of all of the sides there is going to be 3,000. So 3,000 is going to equal 2 times the length times the slant height. Okay, 2 times the length times the slant height. Well, I know that the length is 50. Well, so 2 times 50 is going to be 100. And when I divide both sides by 100, I'm going to get that the slant height here is equal to 30. Okay, so this right here is equal to 30 inches. Now, I know, because I was told that the base is 50, that I know that this distance right here is going to be 25. So I can come over here and say, okay, well 25 inches squared plus the height squared is going to equal the hypotenuse or slant height squared. Okay, so 25 squared will be 625. I'm just going to double check that. Off the top of my head, that's, yeah, 625. Plus height squared is going to equal, well, 300 squared is going to be equal, sorry, 300 squared. Oh, that was terrible. What I meant was 30 squared, is going to be 900. Now I'll bring that over, so 900 minus 625 is equal to 275. And now I just need to take the square root of 275. Now this will be plus or minus. However, the negative one doesn't really make any sense in this context here. So we can say to the nearest tenth of an inch, we've got 16.6 inches. Now, that's me on the calculator here working that through. The square root of 275, so 16.6 inches is the value that we're looking for. All right, so this question says that a wooden square pyramid is to be painted, excluding the bottom. Now, this is the sort of question that you're going to get on an exam, something like this for sure, where there's going to be, it's not the whole thing that's being dealt with here or being implied here. So you're going to have to understand a little bit more deeply about what the formula is saying to understand what you got to do. So the side length of the base is 8 centimeters and the height of the pyramid is 6 centimeters. To the nearest square centimeter, what is the area that will be painted? Well, okay, the surface area is 2ls plus the length of that base squared there. Now the thing is though, we're being told that we don't want the bottom. And remember, that's what that L squared is, length times length there, L squared. We don't want that. So really, all we're interested in here is this 2ls. Okay, well that's simple enough. So 2 times the length of the base there is 4 times the slant height, which is, I don't know. I don't know what the slant height is. I'm going to have to figure that out. Fortunately for us, a long, long dead Greek mathematician gave us a theorem. So we've got the Pythagorean theorem here, and we're very thankful for it. So it will be 4 squared plus 6 squared will equal s squared. 4 squared is 16, s squared is 36, is equal to s squared. So 36 and 16 will be 52. S squared. So now this means that s is going to be either the positive or the negative square root of 52, but obviously this is going to be the positive root 52 because it doesn't make sense to make this negative. So there's my slant height, so I'm going to come up here and make this root 52. And so now, on my calculator, it'll be just 2 times 4, which is just 8, times the square root of 52. Oops. And what does it say here? The nearest to the nearest square centimeter. Okay, well, to the nearest square centimeter, I'll show you what I got there. To the nearest square centimeter is going to be 57, okay, 0.688, so 58 square centimeters. So approximately 58 centimeters squared is what would be painted in this question.
Now we'll find the surface area of a rectangular pyramid.
So now we're going to take a look at the formula for the surface area of a rectangular pyramid, which basically means that the base is a rectangle, not a square. Now, it changes the formula, but the idea is basically the same here. So as we go around the lateral side of the pyramid here, notice that the triangles won't all be the same because the bases will be different. However, the front triangle has a base that's the length of that rectangle. Well, so does the back triangle that comes up. The one on this side has a base of W, the one on this side has a base of W. So the front and the back triangles are the same, so are the two side triangles. Now, the other thing that's different about the triangles here is that the slant height over here will be different than the slant height right there. Okay, and you can see we're using two different variables here. We're using A for the slant height of this one and S for the slant height of this one right there. And those will be different because of the fact that that base is a rectangle. So the surface area is going to be the area of the base, the rectangle. That's just going to be length times width. No big surprise there. Then it's going to be the lateral area of the 4 triangles, which maybe should be written as 2 pairs of triangles, because that's really what we've got here. We've got the front and the back one, which the area will be 1/2 L times A, okay, A being the slant height, and there's 2 of them, so the 2's will cancel. And then here, 1/2 the width times the slant height, and that's going to be, again, multiplied by 2 because there's 2 of them there, and those cancel. So we're left with length width plus the slant height times the length of the base of that triangle, sorry, times the base of the triangle, plus the slant height of the other side here times the width of that triangle at the base there. Okay, so there we go. So now we're going to jump in and do some examples. Okay, so this first question here says to find the surface area of the following. Okay, here we go. So our surface area, as we just saw, surface area is going to be length width plus A length plus S width. That's what we just saw. So in this case here, it's going to be pretty straightforward. Our base here is going to be 16 by 12. So there we go. That's easy. 16 by 12. Good. Now, AL is going to be the slant height of that one triangle times the length here. So in this case, we're actually told what that is. This distance here is 10, so this would be 10 times, and the length there is 16. And then over on this side here, again, we're told what the slant height is. It's 11.3, and then the width there is 12. So this question here is really straightforward, just understanding that the equation, plugging that all in. So now let's enter that. Whoops, sorry, hit something. I hit a couple things there. I think we'll go like this. Let's just enter this all in. So 16 times 12 plus 10 times 16 plus 11.3 times 12. Whoops. And if you've been following what I did there, my multiplication didn't come in there. So 16 times 12 plus 10 times 16 plus 11.3 times 12. And we get whoa, you can't see that, 487.6. 487.6 centimeters squared. Now this question tells us to find the surface area of the following rectangular pyramid, and we're going to round our answer to 2 decimal places. Okay, here we go. And again, the formula for surface area is going to be length times width, that's the base, length times A, That's going to be the front triangle and the back triangle, and then plus W times S, which will be the right side triangle and the left side triangle here. Okay, well, length times width, that's going to be the easy one. That's going to be 6 times 4 plus length times A. All right, well, that's going to be 6. And now I got to figure out what that slant height is. Okay, well, now this is, I know this can be difficult for people here. Kind of bear with me. In order to really see this triangle right here, and I know we've done questions like this before, but I'm going to just take a moment here and talk about it again. That triangle is essentially sticking out. So for me to see what this width is, I have to kind of look at it from this side right here. After all, this distance from here all the way across to here would be the same as this right here, 4, because these sides would be considered parallel. So this is only going to be half of it. So this distance right here is going to be 2. Okay, so this is 4, this has got to be 2. Now the height of that pyramid is 8, and that's the height we're going to use for this triangle. That's what we're going to use to figure out what A is. So we know that 2 squared plus 8 squared is going to equal A squared. Now I'm just going to do this a little bit quicker here. So that's going to be 2 squared is 4 plus 8 is, well, 8 squared is 64. And so that's going to give us 68 is equal to A squared. Okay, now I'm going to take the square root of both sides here. So, and when I do that, I would get the plus or minus square root, but we're not going to do that. We're only going to worry about the positive one. So 68 is equal to A. Now, at this point right here, we have done a little bit of work with radicals in the past here, so I should be able to simplify that. If you play with that a little bit, you would notice that 68 is the same as 2 times 2 times 17. So I can actually say that A is equal to 2 root 17. Now, in a second here, I'm going to plug that into my calculator, and I'll get a value for that, a decimal value. But it's not a bad thing to keep that in mind and to practice that. So up here, this is going to be 2 root 17. Now, I have to add to that these other two triangles here. So here's the slant height. Now that I didn't draw that at all correctly. Try that again. Right there. That's what I wanted. And to see this triangle carefully, I have to look at it from the front here, because this is extending off to the side. This base of this triangle, if you were to extend this line all the way across, bear in mind that that would be 6. Okay, because that runs parallel to this side right here. So this is 6. This one would be 6. So this distance here is only half of that, so it's got to be 3. So the triangle that we're working with right now, if this is S here, will be 3 squared plus 8 squared is equal to S squared. Well, 3 squared is 9, okay, plus 64 is going to get us 73. So S squared is going to equal 73, and I'll take the square root of both sides, and I'm only going to take the positive one. Now, I don't think 73 can be simplified at all, so that's as far as I'm going to be able to take it. Which means, okay, that what I want to put here is going to be 4 root 73. Now it's just about going to the calculator and entering that all in. So 6 times 4 plus 6 times 2 root, 2 root 17, got to get out from underneath there, plus 4 times root 73. Press enter, and we're going to get that the surface area here is 107 point, I think it's at 2 decimal places, yep, 0.65. So approximately 107.65, and there's no units here, so units squared, because it is a surface area that we're looking at. Okay, so in this question we're being told to calculate the slant height S of the right square pyramid. Now there's that word right. Okay, whoops, that word right there. Now, essentially what that means is that, again, that apex right there is directly above the center. Whoa, you can't even see what I'm doing. Directly above the center of the square there. Okay, so it's not off to the side. It's not like you've got a pyramid that's doing something like this, right? Which is totally possible, but that's not what we're talking about. So anyway, I don't want you thrown off by that word right. Okay, so this right square pyramid to the nearest 1/10 of a centimeter. Okay, here we go. So we know that the length of the side here is 4.5. Okay, and we know the surface area is 129.5 centimeters squared. So the surface area of this square pyramid here is going to be, remember how that works here. In fact, let's go back, because we've got the surface area formula, yoink, right there. Okay, 2ls plus 1/2 L squared. So this is the length of the bottom times the slant height plus the length of the bottom squared. So come back to here, so it's going to be 2ls plus L squared. Now we know that this is 129.5. We know that the base here is 4.5. What we don't know is the slant height. And then again, we got the 4.5 over there squared. Now this is really just about understanding order of operations more than anything else here. So I've got two terms on the right-hand side. I need to get the one with the s in it by itself because I want to isolate the s. So I'm going to subtract the 4.5 squared. So it'll be 129.5, whoops, and we're going to subtract the 4.5 squared from both sides. Okay, and actually I'm quite lazy, so on the right hand side, like I've subtracted this right here. Basically I'm moving it to this side, and if it's positive on this side, it becomes negative on this side. Now I'm going to be left with this term on the right hand side, but I am so lazy, I'm just going to deal with this right now. 2 times 4.5 is 9. That'll be just 9s here. And so now the last thing I'm going to do here will be to take this 129 point, whoops, wow, I don't know why I wanted to write a 2 there, so weird. 129.5 minus 4.5 squared. We're going to divide all of that by 9, and that's going to get me s there. So now, and I know that I've mentioned this before, but we need to just say it again here. Part of the issue in this chapter here is going to be entering things into the calculator correctly. So because there are two terms in the numerator, I need to put parentheses around that. Minus 4.5 squared, and I got to close the parentheses. If I don't do that, then I'm not going to be doing the subtraction first. And remember that that bar implies a set of brackets around the numerator. And then I'll divide by 9, press enter, there we go. So to the nearest tenth, 12.1. So, whoa, I'm giving you a little bit too much here. S is going to be approximately 12.1, what were our units? Centimeters.
Finally, we'll look at the surface area of a sphere.
All right, now we're going to take a look at a sphere. A sphere and a hemisphere. So the surface area of a sphere, without going into too much reasons as to why this is the way it is going to be 4 pi r squared, which is actually kind of an amazing result, because what that means here is that if you were to cut a sphere perfectly in half, okay, straight through the center there. Now bear in mind that the area of that circle that you would have exposed, the area there would have been pi r squared, that radius there squared. So what we're saying here is that the surface area of the sphere is simply 4 times that area right there, which is actually a really simple, straightforward, interesting relationship. Now, over here, if we're talking about a hemisphere, we've got to be a little bit more careful, and this 3 might be a little bit confusing here, because at first glance you might look at this and say, well, wait a minute. It's half of a sphere, how come it's 3? Well, let's talk about that. So the surface area of a hemisphere, if your gut instinct tells you, wait a minute, it's got to be half of a sphere, so shouldn't that just be 2 pi r squared? The answer is you're right. You're right. But what that is that you've just figured out here is that's this bit right here. Okay? That's this bit right here. What about that exposed circle that you've got in the top there? Well, the area of this, that is an additional pi r squared, for a total of 3 pi r squared. But you really do need to be aware of what that 3 signifies here, because there will be circumstances in questions that you do below here where you're actually only interested in that lateral surface area. You're not really interested in the base, or sometimes vice versa here or whatever. But just be aware that that 3 pi r squared actually consists of 2 distinct parts that we're putting together to get the surface area of a hemisphere. So in this question we read that the diameter of a softball is approximately 4 inches. We're going to determine the surface area of the softball to the nearest square inch. Well, okay, well, that's pretty straightforward here, because surface area is simply 4 pi r squared. And so what have we got here? 4 pi, and the diameter is 4 inches. Now, okay, that's diameter. So I got to bear in mind here that means the radius is only going to be 2 inches. Okay, and so this will be, well, I can simplify this down a little bit. 2 squared is 4. Order doesn't matter with multiplication here, so 4 times pi times 4 is really going to be just 16 pi. And so my answer is going to be approximately, just go to my calculator, multiply 16 by pi, to the nearest square inch would be, well, 50 square inches approximately. Right, this next question says that the surface area of a soccer ball is approximately 250 square inches. Okay. And then the question is, what's the diameter of the soccer ball to the nearest tenth of an inch? Okay, well, I mean, when we say the nearest tenth of an inch, because we know that this is only approximately, this is going to be not exactly all that accurate, but it doesn't matter here. So surface area is going to be 4 pi r squared. Now notice diameter doesn't show up anywhere in here, but diameter is very closely related to the radius here. The surface area we're being told is 250. So this question really is about simply manipulating this very straightforward equation here. I want to know what r squared is first. That's my first step. I got to kind of chip away at this problem to get to that r, and I'm going to get to r squared first. So I'm going to divide both sides by 4 and pi. So that means on the left-hand side, this will end up being 4 pi. On the right-hand side, when I divide both sides by that, it'll go away. So I'm left with r squared. So 250 over 4 pi is equal to r squared. So therefore, I got to take the square root of both sides, and that's going to introduce a plus or minus, but I'm only interested in the positive. So r is going to equal the square root of 250 over 4 pi. Now, let's go to our calculator, and we would enter in the square root of 250 divided by 4 pi. Press enter, and we're going to get 14.01, but before we go very far here, everybody, that is incorrect. That is incorrect. And this is a good moment for us to talk about this, and I did that on purpose, okay? And I just want you to take a couple seconds. I'm just going to pause here for a moment. Please take a look at what I've entered here. See if you can figure out what I did wrong before I tell you what I did wrong. Okay, so hopefully it's clear to you what I did. If not, let me just go up here and let me fix it. I'll come back into our equation here. What I did was I divided 250 by 4, and then I multiplied the answer by pi. The calculator is assuming that pi is up in the numerator with a 250. If I want this to work correctly, then I actually have to put parentheses around that 4 pi. You have to understand that the calculator does not know what the formula is. It doesn't, oh, I get you, yeah, I know what you mean. No, it doesn't. It's doing exactly what you tell it to do. So you have to know how to use the calculator, okay? And don't just assume that you're 100% familiar with it. Okay, make sure you get what the calculator's doing. I mean, if you're the type of person who goes in and you think, yeah, I know, I would have just done that, well, you would have got the wrong answer even though you did the algebra correctly here. So please make sure you're careful with this. The answer here to the nearest tenth is 4.5. Okay, 4.5 inches. So in this question we read that the center of a donut is removed to form formed to make a sphere of dough with a diameter of 2.5 centimeters. A batch of these spheres is to be covered in sugar glaze, and there is enough sugar glaze to cover an area of 4,710 centimeters squared. So how many spheres can be glazed? Okay, so we got to figure out what the surface area of one of these little things is, and then divide that into the total surface area we can cover to see how many pieces we've got. Well, we know that the diameter is 2.5 centimeters, but that's not what we need. We need the radius, which would be 1.25 centimeters. So the surface area of a single little donut hole here will be 4 pi 1.25 squared. Okay, let's figure out what that is. So 4 times pi, I'm just going to go to my calculator, times 1.25 squared. Okay, and we've got basically approximately 19.6 centimeters squared. Now, this is what I got on my calculator. I'm actually going to just leave that in there for right now. This is what I wrote down, but this is actually the number that I'm going to use when I go to the calculator next. So if I want to figure out the number that I can make here, and I'll just use that symbol right there, that's going to be the total that I've got, 4,710 centimeters cubed, divided by that 19.6. This is how much each one takes. This is how much I've got. This is how much each one requires. And so now, on my calculator, I will take the 4,710. There's my total. Each one of those takes that 19.6. So to get that, I'm going to press second negative sign. Whoops. Because that's the answer right there. And that's the answer from the previous question. So that's going to be this number right here. Press enter. And we get 239.87. Okay? So 239.878, and that goes on and on. Now the question is, how many can I actually cover here? And the answer is, you have to round down. Okay? There isn't quite enough to finish up that 240th one. You're just so close, but it wouldn't get covered. In fact, just a very little bit of it wouldn't be covered. But still, it wouldn't be covered. So we have to round down. So therefore, the answer is 239. Now, I'm going to show you just a little bit of notation. Just if we're going to geek out a little bit here. This notation right here tells you to round down. It's called a floor function. It's going to take that number. It's like a set of square brackets, just without the top there. Square brackets, and that tells you to round it down. Now, you don't need to know that, but you're better people now because you do. So 239 donut holes.